That's awesome. All right, so how are we going to do this problem? I hear that it is so easy, so let's go ahead and do it.
So you take 41 and then
add
plus 56, and that's 97. And then 97 minus 86 is 11, and then 86 minus 11 equals 75.
And then the answer is 75.
Oh my gosh, you said that far faster than I can write.
Hey, yeah, that's 11, and then 86 minus 11 equals 75 students that are taking one class, because it's asking how many take only one. Yay!
Yeah, that's pretty quick. The way I did it, because I love equations, I said that there are X number of students who are taking both. So that means for math, we have 41 minus X. For art, we have 56 minus X. And I know that this plus this have to equal 86. And I just solved for X. But your way is faster.
Plus this.
So I would have done 41 minus X plus 56 minus X. So these two cancel out.
Oh God, no thanks.
Oh, it's not that difficult, Walter.
Come on, Walter.
So 41 plus 56, that's your 97 right there. Minus X is equal to 6. So then minus 97, and you get negative X is equal to negative 11, so clearly X is equal to 11. All right.
Okay, yeah.
So yeah, it really isn't that bad. It's just train tracks.
Yeah.
All right, so this one I found confusing. Did anyone else find it confusing?
Yes.
The power.
I didn't even know why they had it in the 3x3 thing.
Okay.
I didn't know that was important.
So here's what's happening. We have 9 total factors of a number. So we'll call the first factor A1. Why they didn't use F for factor is beyond me. We have A2, A3, and they said it's a 3x3 array, so this is A4, A5, A6.
Wait, was this the power of 5 or no?
A7,
No.
A8,
Was it?
and A9.
No, that just means that's subscript, which means that was the number it was.
Right. That's exactly right. So it's just saying what each number that the factors essentially are different. And it says that A1 is 1. It says that A6 is 44.
Whoa.
So here's the thing. All of these numbers have to be a factor of one number. So we need to figure out what that one number is. So the first thing I'm going to do is I'm going to take this 44 and I'm going to take it into prime factorization. And in prime factorization, it's 2 to the second times 11 to the first.
Okay, Mr. Francie, I have a question.
Yeah?
How do you know when to put stuff into prime factorization, like during a math competition?
That's a great question. Because it's talking about factors.
Okay.
As soon as it starts talking about factors, I don't always have to do prime factorization, but it's a good bet prime factorization is going to be on the menu. All right, so I can't help but notice I only have 9 factors. The only way to have an odd number of factors is if you have a square number.
Oh, yeah.
That's the only way to have an odd number of factors. So I know that this number has to be a perfect square. And so I'm looking at 2 to the second times 11. Well, wait a second. To have a perfect square, I need to have factors that are squared, right? Mm-hmm. So this number is going to have to be 2 squared times, come on, times 11 squared.
Wait, what? I have no idea.
A perfect square, I'll explain it. A perfect square has to have factors that are squared, or factors that are, I think you can get away with it if you have factors that are to the 4th power. I think that it still get a perfect square. So like if you add,
Why is it a perfect square again?
If you add 2 to the 4th, you would get 16, which is still a perfect square.
yeah, but not always, right? So,
Because it's 8.
so 3 to the third, 3 to the
2 to the 4th is 16.
right. Yeah, 2 to the 4th is 16, which
2
is
to the
also
4th is
perfect square.
16, and 4 squared is 16.
Yes. Yes.
Wait, where did we get 2 to the 4th?
Oh my God.
We don't know.
Walter, just hold on a second, buddy. I'll get you there.
Oh.
Let's go through the problem and then we'll back up. Okay? So we know that this has to
Where are the numbers from 16 to the 4th?
can we move on? So we
Sure.
know that 8 the ninth factor has to be a perfect square because only perfect squares have odd numbers of factors. Otherwise, if you have a non-perfect square, it will always have an even number of factors. The only way you can have an odd number of factors is if you have a number times itself that gets your new number. So that's why we know it has to be a perfect square.
Yeah, okay, that makes sense.
Okay, so, and we know that the sixth factor is 44, which is 2 squared times 11. So we know that 2 and 11 have to be factors of our perfect square. And we also know that to find the number of factors that a number has, you take the prime factorization exponents, add 1, and multiply. So 2 plus 1 is 3. 2 plus 1 is 3. 3 times 3 is 9.
Nice.
So we know that 2 to the second times 11 to the second has 9 factors. We're looking for a number that has 9 factors, and 44 is one of them. Okay, that's good. So 2 squared is 4, 11 squared is 121. So 4 times 121 is 842. No, 840. I should write it down.
I have no idea.
It's 484. Because 4 times 121 is 180. So then we want to know what this is. Well, we could figure out all 9 of the factors, but we don't have to. Because we know that this number right here has to be half the total value.
Yeah, that makes sense. So 242.
242.
Wait, how do we know it's half?
Because the largest factor any number can have is half of its value.
Oh,
Because
yeah.
it's
Times
2
2,
times,
yeah.
right. And so right now we can stop. Right now we can stop. But if you really wanted to, this would be 2 to the first. This would be 2 to the second. Right.
No thanks.
No thanks. Well, I still think that you would be somewhat interested. So then this would be 11 to the first. This one would be 11 to the first times 2 to the first. This is 2 to the second times 11. And your seventh factor would be 11 times 11. And there you go.
Wait,
So-
why is there 2 11? It's gonna confuse me.
Well, because to have a perfect square number, you have to have a factor squared. Right. So then, once we know that 44 is a factor of the number we're looking for, 44 has 2's and 11's, so this number has to have factors that are 2 and 11.
Yeah.
And so once we have this number, just divide it by 2 and we get that number.